Today we're going to compare proportional relationships and use equations to solve further problems. So this first problem says Elena babysits her neighbor's children. Her earnings are given by the equation y equals 8.40x, where x represents the number of hours she worked and y represents the amount of money she earned. Jada earns $7 per hour mowing her neighbor's lawns. Who makes more money after 12 hours? And how much more do they make? Well, in order to find this, first I want to make sure that my work is clear and I don't mix anything up. So whenever I'm going to compare, I'm going to split my paper and break it up into two columns. So here I'm comparing Elena's earnings and Jada's earnings. Now they already give me the equation for Elena. Y equals 8.40x. So this shows the relationship between how much she makes and how many hours she works. We can do the same thing for Jada, except Jada earns $7 per hour mowing her lawns. So her equation is going to be y, again, the amount of money they make. She gets $7 per hour. So an equation that we could use at any point would be 7x. So again, these equations show the relationship between the amount they earn and how much they work. So I'm going to jump down to the second equation or second question for B. It says, what is the rate of change for each situation and what does it mean? So for Elena, because to understand how to solve A, we have to have the rate of change. So the rate of change for Elena is $8.40. And what this means is $8.40 per hour. She gets paid a constant rate of $8.40 for every single hour. That's how much her money, her earnings, the Y, changes by. Jada, her rate of change is $7. And for it's still the same thing, that represents how much she gets per hour. Every single hour is increasing her money by $7. That is the constant rate of change. So now when I go back to the original problem, it says who makes more after 12 hours? Well, now I need to figure out where does this 12 hours go? Again, 12 is representing time, it's the hours. If I go back to my original problem, it tells me that hours are represented by x. So I need to plug 12 in for x. How much money do they make? So y again, y is the money. I want to find out y. I want to find out how much money she makes. She makes $8.40 for 1 hour, but I want to know how much she makes after 12 hours. When I multiply these out, $8.40 times 12 gives me $100.80. So the same thing for Jada. To figure out her earnings, her Y, $7 per hour. She's mowing for 12 hours. So when I multiply that, I get $84. So Elena's going to earn $100.80 after 12 hours. Jada's going to earn $84. So my question, who makes more money after 12 hours? Elena does. And how much more? To figure out how much more something is, I'm going to subtract. So I need to do $100.80 subtract 84. And I get 16.8, which in terms of money, so Elena makes more money by $16.80. So again, if we have our equation, then we can use it to solve any problem given what numbers we have for our variables. So this last question, C, is based on the problem we just did in our two equations of Elena and Jada. It says, how long would it take each person to earn $150? So right now I see a difference between this question and the last question. This question gave us the hours and it asked how much they would make. This problem is giving us the amount they made and how many hours that they would have to work. So when I look back at my equation, I'm given my dollars and I see that Y represents the money. So the 150 this time, we're not going to plug in for X because X represents the hours and Y is the money. So if Elena wants $150, she's going to have to, her rate is $8.40, and we want to figure out how long she's going to have to work. So this is a one-step equation. To solve for X, I just divide by 8.40, and I get a really long decimal. So I get 17.8 equals X. So if I think about it in terms of hours, that's really, really close to 18. She's going to have to work 18 hours in order to make $150. She would make just over $150, but she's going to have to work that much, 18, if she wants to make $150. So same thing with Jada. Again, the 150 is going to go in for Y. That's my money. She's going to make $150 by mowing $7 per lawn, or $7 per hour. So I'm going to divide both by 7. Now this time, when I divide, I get 21.4. Now, even though with rounding, technically that would round down to 21. However, she has to work 21.4 hours. That means if she just works 21, she will not make 150. But yes, I could round up to 22. However, 21.4 is very close to 21.5, which is the same as 21 and a half hours. Sometimes you mow lawns for half an hour. So that's very possible. So she would have to work for 21 and a half hours, whereas Elena would only have to work for 18 hours because she gets paid more per hour. Her constant rate is more. Therefore, she's going to get to $150 quicker. All right, look at this next one. It says, Claire and Han have summer jobs stuffing envelopes for 2 different companies. Claire's earnings can be seen in the table. Han earns $15 for every 300 envelopes he finishes. Who would make more money after stuffing 1,500 envelopes and by how much? So I can see I'm comparing 2 people, so I'm going to split up my paper into Claire and Han. This problem does not give us any equation, but I'm going to create an equation first so that then I can use that to solve. So again, I need a Y. I need to find my constant. How much is it for every single envelope? My number of envelopes is going to be my X, and my money is going to be my Y. Remember, your Y value is your dependent variable, and the amount you make depends on how many envelopes you stuff. So, since this is a proportional relationship, to get my constant rate of change, I can take my Y value and divide it by my X. So we don't want to get confused and say, oh, 400 is bigger, so I'm going to start with 400. No. It's $40 divided by 400 envelopes. So when you think about it, if you're stuffing one envelope, you're probably not going to get paid for that much for that envelope. When I divide, I get 0.1, but this is money. Again, this is cost over envelopes. So I get 10 cents, and that is, when I jump down and I look at letter B, that is the rate of change for Claire. The rate of change, the constant rate that she's getting is 10 cents for each envelope she stuffs. So that means I can now write the equation. To get the amount of money she earns, Y, at any time, we can take her constant rate of 10 cents and multiply it by the number of envelopes. Han doesn't give me a table, however, it does tell me that he gets $15 for 300 envelopes. So again, I can consider it the same thing, Y over X. He's getting $15 for 300 envelopes. So when I divide that out, I get 0.05. So that means it's 5 cents for one envelope. So that is his rate of change. It's 5 cents for each envelope. Every single envelope increases his earnings by 5 cents. So then his equation is going to be Y. His amount earned is by taking his unit rate, how much he earns for one, and multiplying it by how much? How many envelopes? So now back to the original question, who would make more money after stuffing 1,500 envelopes? And remember, my envelopes was my X value, so I'm going to plug in my 1,500 for X. I'm looking for the money, so I'm looking for my Y. So I'm going to do 10 cents times 1,500, my number of envelopes, and I get 150. So she is going to make $150. So for Han, he gets paid 5 cents, so automatically I know he's going to be earning less. I need to multiply 5 cents, how much he gets for one, by the 1,500, and I get Y equals 75. So he's going to earn $75. Claire, is going to earn $150. So who makes more? Claire, by, because it's asking by how much. To figure that out, I do 150, subtract 75, and I get 75. So she makes more. Claire makes more by $75. Okay, and this last one says Tyler plans to start a lemonade stand and wants to make sure the recipe doesn't use too much lemonade mix, but still tastes good. Recipe 1 gives us the equation Y equals 4X, where X represents the amount of lemonade mix and Y represents the amount of water. Because remember, think about it. You have the lemonade mix, which is usually like a powder, and you add water to it, and you stir it up to get your lemonade. Recipe 2 is in the table. So the lemonade mix, I'm going to go ahead and label that X, just like it says in here, and then the water is going to be the Y. How much water you need depends on how many scoops of the mix you put in. Okay, so if Tyler has 16 cups of lemonade mix, how many cups of water should he put in for each recipe? So I have 2 recipes. Recipe 1 already gives me my equation. That is saying 4X. So that means I need 4 cups of water for 1 cup of lemonade mix. Recipe 2 doesn't give me that, but I do have enough information to find my constant rate. Again, it's Y over X. So this is water over lemonade mix. 50 cups of water. I need 10 lemonade cups. So when I divide that out, I get 5 over 1. So 5 water cups for every 1 lemonade mix. 5 water cups for 1 lemonade mix. So that is my constant rate. I need 5 for every 1. To get the amount of water, I take 5 times however many liters or however many cups of lemonade mix. So I'm going to go down here again. So recipe 1, their rate of change is 4. And that means it's 4 water cups per lemonade mix. Recipe 2 is 5 water cups per lemonade mix. So I know just from writing that, since that one has more water in it, it's not going to be as strong as recipe 2. So now going back up, Tyler has 16 cups of lemonade mix. The lemonade mix, remember, was my X value, so I'm going to plug the 16 in for X. So to figure out how much water, my Y, I'm going to do 4 times the amount of lemonade mix, and 4 times 60 is 64. So recipe 1 needs 64 cups of water. For recipe 2, I need to do 5 cups for every lemonade mix. So I have to do 5 times the 16 that I have. So that means I need 80 cups of water. 64 cups of water for recipe 1, 80 cups of water for recipe 2. I can tell that recipe 2 again is going to be weaker. It's not going to be as strong because it has more water in it than recipe 1 does for the same amount of lemonade mix.